Working on a traction engine which is similar to a Minnie, part 8, fitting the wheels, cleaning and then fitting the hubcaps, followed by making a couple of driving pins, and now the engine can move along the workbench. I wanted this engine to look a little bit like a Walt Disney traction engine. I gave this a bit of thought and painted the wheels silver, which I suppose is close to steel. I couldn't leave the spokes and the rims in steel because they would rust. And now with the silver wheels it looks like a fairy tale machine, and I'm quite pleased about that. This engine has hubcaps on the rear wheels only, and I think before I do anything else I will clean them up in the lathe. Here I've centred the first one in the chuck using the tailstock chuck, and now I can clean the outer edge first. I'm using my small Warco M180 lathe which is in my smaller workshop, and I must say that I really am impressed with the performance of this lathe considering it is such a small machine. Even though it is small, it still has a centre height of 3.5 inches like a Myford. This lathe currently sits on foam pads on the end of my workbench, so if you see it moving about in the video, that is why it's moving about. I cleaned the outer rims first as you've just seen, then I turned them around and centred them in the chuck using the tailstock chuck to clean the other end, and now they look like this. I'm about to fit the first of the wheels. These wheels spin free on the axle, which means that if you remove the drive pin that I haven't yet made, you can use traction engines like this as a winch, but the drum on this one is a dummy. It's just there for effect. I've lubricated the axle using steam oil because it's sticky and it stays where you put it. What I need to do now is tap in the driving pin into the axle. Here it is. It's not a very tight fit, just tight enough so it doesn't fall out, and it's actually held in place by the internal diameter of the hubcap. After applying a small amount of oil to the end of the axle, it was time to fit the hubcaps in place using these very tiny nuts. These days, owing to my age and declining eyesight, this is a difficult job. Thankfully, my mental ability is not declining very much. And now it's top tip time. This is the first one in this episode, how to locate very tiny nuts on equally tiny studs. I use a watchmaker's screwdriver to centre the nut on the stud. It's easier than it looks. Once the nuts were engaged on the studs, I carefully tightened them using a very small spanner. These parts are very fragile, so I'm being really careful not to over-tighten them and shear the studs off. For some model engineering jobs, you really do need a touch like a midwife, very gentle yet firm at the same time. The first of the hubcaps is now bolted in place and looks quite good against the silver wheels. I turned the traction engine around and now it's time to fit the hubcap at the other end. Starting with some lubrication and then just tapping the pin into position, and maybe a little bit more lubrication at the end. Obviously, fitting the second wheel is exactly the same as fitting the first one, so I'm not really going to dwell on this for too long. And in no time at all, the second hubcap is bolted in position. The next job is to make some driving pins, because these wheels spin free on the axles. But before that, I think it's a good idea to fit the front wheels. There are no hubcaps for the front wheels and no sign of there ever being any, so I'm following the same tradition, because really I don't want to make hubcaps and fit them to the front wheels. And now for the second top tip time in this episode. This one's about fitting very small split pins into holes on axle shafts. I use a Stanley knife blade to initially open the pin, then I use a small pair of very long nose pliers to bend the ends of the split pins around the axle. I always do it this way because I firmly believe that is the way split pins are meant to be fitted. I inserted a long piece of 3/16 of an inch diameter brass into the drive pin holes, so now the engine can drive itself up and down the bench. Normally traction engines have a differential gear, this one doesn't, it's just one wheel drive. And for that reason I'm going to make 2 steel drive pins, but only one of them will be long enough to drive one of the wheels. To make these driving pins I'm using a piece of steel. First of all, I turn it to a diameter of 3/16 of an inch along its length. I can't just use a piece of 3/16 of an inch steel because I need a fancy bit on the end. Here I'm using a parting tool a long way out from the tool post, and how this works I do not know. The quick change tool holder is an aluminium one and it was very cheap. I bought it as an experiment, and so far I can't fault it in any way. In this clip I've changed the position of the tool post to hold the tool so I can cut a special shape on the end. The good thing about this Warco M180 lathe is the speed control. It's infinitely variable from nothing up to 3000 RPM, and you can always get the speed and feeds right. Quite unlike the ones in my main workshop, which need manual intervention, moving pulleys to change the rotational speed. I didn't go all the way through the piece of steel. Once it got to be thin enough, I broke it off. Now it's time to turn the shape at the end of the first drive pin to how I want it to be. I don't want it to be round, I want it to be, well, more or less this shape without a sharp point on the end. After turning the end, I used a small file to shape it further, being very careful not to catch it in the chuck too many times. This is only a small lathe, but it could do a lot of physical damage if you get it wrong. And being a keyboard player, playing professionally in the recording studio very frequently, I do need all of my fingers. I alternate between using the file and the wet to dry sandpaper, but it's still not quite the right shape. The end is still a bit pointy and I'm flattening it off using the file, but there is a better way, and this leads me to top tip time number 2. Why not use my Proxon motor tool fitted with a drum sander to shape the end? This works perfectly. It's very quick to do, doesn't give a particularly good finish, but that's not an issue because you can do that with the file and the wet to dry sandpaper as shown previously. This shape is just how I want it. I'm not going to polish it up because the polishing spindle is in the main workshop and I'm in my second workshop. I press the drive pin through the wheel and into the drive gear, and now the engine can run under its own steam, or in this case compressed air. I'll stop talking for a while so you can see it running up and down the bench. I really do like this thing. It's quite novel. It's a bit strange, and it's one of those models that is so well made it just does not require painting. I have a sterling single in 5-inch gauge which is like that. The workmanship is stunning, although I don't ever think I'm going to finish it, so I will be putting it on the market shortly. There will be the usual 10% discount for my Patreon supporters. I'm going to put it on the market at £4,000. It's actually worth a lot more than that, but I'm going to offer it to any of my Patreon supporters for £3,500, which is extremely cheap for such a thing. More about that in an episode specifically about the sterling single. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainstream Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.